Alright, so here's the product property of logarithms. Anytime I have two logs with the same base, when the bases are the same and those logs are being added, then the product property says that I can rewrite this with the same base and just multiply the two values. Okay, so this is the product property. So think about it. If their logs are adding, then I multiply those. So let's look at example 7. I'm going to rewrite this as just one log. So I have the same bases and they're adding. So I'm going to rewrite this log base 2, and it's going to be 8 times 3. So I just multiply those two. So I can simplify this log base 2 of 24. So let's see how we can use one of those to solve a problem. So if we look at example 8, all right, I notice that I have addition here, so I'm going to change this to one common one. So log 5, and then remember they're adding, so I multiply. So 3 times x equals log 5 of 12. So now they have the same base, and we can use that equality property of logs. Since the bases are the same, there's an equal sign. I can just set those values equal. Divide by 3, and we get x equals 4. So this is the product property. Remember, when you're adding logs with the same base, you just can change it into one by multiplying. And you can work backwards. If you have a multiplication, you can break it apart into addition. All right, so let's look at the quotient then. So if we add the two, then we multiply. Then with the quotient rule, when we have the same base and we're subtracting, then what we're going to do is divide. So it's the first one divided by the second one. Okay. So let's look at example 9. And then this one asks us to simplify if we can. So if we look at this, they're the same base. So log 2. And then I'm going to divide 32 divided by 4. 32 divided by 4 is 8. So log base 2 of 8. And we can try to simplify this. 2 to what power gives us 8? We know 2 times 2 is 4 times 2 is 8. So this is actually just 3. Okay, because remember, it's asking you for the answer to a log is the exponent. So 2 to the third power is 8. So we just simplified that one. And then you might be asked to have one where you solve it, just like with the product. So if we look at this, we have 2 that's the same base here, where they're all the same base, but we have subtraction. So let's make this one problem. 8 divided by x equals, and then leave the other side. So now we have an equal sign with 2 logs in the middle. So this is the equality property. I can just set those values equal. And so here I can multiply by x. So we get 8 is equal to 4x divided by 4, and x is equal to 2. Okay, so this is how you use the quotient. So we have the multiplication, or the product property, and now the quotient property. And then we have a power property. If you have a log that has a number out front, a power, this is the same thing as log a m raised to that power. So you can always, if you have a log with a power, then you can always pull that power, that p out front, or if you have the p out front, you can pull it up to your value raised to that power. So let's look at one of these, example 11. We're going to rewrite it, and then we're going to simplify if we can. So I have a p out front, a 3, so just think about I'm moving that power to this value. So this could be log 8 of 2 to the third power. And we know 2 to the third power is 8. So log 8 of 8, and this is just 1. Remember our one of our special properties. So that's just 1. All right, so let's try again with where we're going to solve for x. So remember, if I got a power, we can move it to a number in front of the log. We can move it as a power. So log base 5 of 4 to the third equals log base 5 of x. Okay, so 4 to the third power is just 64. So log 5 of 64 equals log 5 of x. Since the bases are the same, then 64 is equal to x. Okay, so here's how you can use the power property. Now, let's look at some of them together. So we're just going to solve some where we have some values and we want to solve. So example 13. What I always look at is see, is there any way to condense it, make it into one log? So I have a log 2 here, a log 2, I'm subtracting. So let's change this using the quotient rule. So remember, when I subtract, I just take the first number and divide it by the second one. And then that's equal to 3. Now, for this one, I don't have a log equal a log. So I cannot put 4x plus 10 divided by x plus 1 equal to 3. But I do have it in a one-form log, so I can change this to exponential form. 2 to the third power, remember the base raised to the power, equals, and then have it set equal to this value. Now we can solve this. 2 to the third is 8. So what we're going to do is multiply 8. I'm going to do this in one step. Multiply both sides by the x plus 1, so I can cancel that. So we have 8 times x plus 1. Remember to distribute that. Equals 4x plus 10. So we have 8x plus 8 equals 4x plus 10. Subtract your 4x from both sides. You get 4x plus 8 equals 10. Subtract 8. And we get 4x equals 2. Divide by 4. And x is 1/2. Okay? So really, it's a little lengthy, looks lengthy, but it's not. Remember, we're just solving an equation. So remember, just get it simplified to one log, and then you can solve it from there. All right, so let's look at example 14 then. So here we have log base 4, but we're adding. So now we're going to use that product property and multiply these. So x times 2x plus 1. Don't forget that when you multiply, you're going to have to distribute. So we're going to have to remember that. Okay, so let's go ahead and distribute that to simplify this. So log base 4, or you could see that these are equal. So I'm just going to set those values equal, and we can go ahead and get rid of those logs. So I'm going to multiply this out. So 2x times x is 2x squared plus x equals, and then I'm just going to set it equal to x plus 2 on this side. We subtract x, we get 2x squared equals 2. Divide by 2, we get x squared equals 1. Take the square root of both sides, and x is equal to plus or minus 1. All right. Let's go to example 15. I might have to have a little extra room. I'm going to go ahead and go back and erase this just to give me room here. All right, so on this one, you notice that we have the same logs, but I have this 3 out front. So let's use what we know, the power rule, to get this 3. Remember, we're going to take it and make it a power on this x. So we can say log of 8 plus log of x to the third equals 3. Now, the reason why I want to do that is because now these are the same base, and I can just multiply those two, and I don't have to worry about that 3 out front. So we can say log, we're using the product rule now because they're adding, log of 8x to the third equals 3. Now, we have a log equal a number, so here's where we got to change it to exponential form before we can solve it, because we don't have a log equal a log. So we cannot say 8x to the third equals 3. So this is actually the base. Remember, when I don't have a number, the base is 10. So 10 to the third power equals 8x to the third. So 10 to the third, I know that's just 3 zeros, so 1,000 equals 8x to the third. So we take 1,000 and divide it by 8. So let's divide by 8, and we get 125 equals x to the third. Now to solve for x, remember we got to take the cubed root, and the cubed root of 125 is 5, because 5 times 5 times 5 is 125. So our answer is x equals 5. And so here's how you can use the property of logs to solve for x.